Polynomials is the next topic, so that's just another word that we're going to learn. So polynomial just means any function that has only positive indices. So here we can see I have 4, 3, 2, that's technically 1 and 0. So they're all positive indices. So this is a polynomial. And we talk about polynomials as what their order is. So an expression with order 2, that just means the highest power or index you have going on. So that's an example of a polynomial that's order 2, which we also know as a quadratic. So an expression that's order 3 would have the highest term as a cubed, so that's a cubic. And order 4 would be a quartic. So order is the word I'm talking about when I'm talking about the power, and if I'm talking about like order 3, that is the highest power. So with our functions, instead of using a y now, we use this f of x or p of x or anything, which just means this is a function or a polynomial where x is the variable. So x is the thing that can change. So the first thing we want to do with polynomials is substitution. So here I have f of 0. So that means I am going to, instead of writing x in all those spots, I'm going to write a 0. 0 cubed, which is negative 7. So I know f of 0 equals negative 7. I can do the same with a 2, so I'm just replacing all of those x's with 2's. Oh, sorry. Which we could then solve, and then this one just subbing them all in with negatives 1's and then solving it. So that's literally all we're doing, substitution, which is going to become a very important skill as we learn the rest of the polynomial stuff. The other thing we can do with polynomials, this is a more complicated substitution question. So this is a more complicated substitution question. So this is saying p of 2 equals 12. So that just means if I sub 2 in for all those x values, my answer to that would be 12. So I can also write that as 12 equals 3, 2 cubed minus, so all I'm doing is subbing in that 2 and making it equal 12, because that's what they've told me. So then I can simplify my maths, so 8, 16, 24. So we're doing this because there's an algebraic term in our polynomial. I don't know what that a is, so I want to solve out for it. So that equals 22. So I can figure out that a equals negative 5. So sometimes it's a bit harder. Here we have 2 unknowns, but we also have 2 things they've told us. So that's going to end up as a simultaneous equation. 7a, Language of Polynomials, page 249, questions 1 to 4. Another thing we want to be able to do with polynomials is actually combine them. So that's something we can do. We can add, subtract, multiply and divide polynomials. We'll do division later, but addition and subtraction is very straightforward. So here I've got my polynomial p of x, and I am adding it to q of x. So that's literally all I'm doing. And then I simplify, so that's 5x squared plus 5x minus 10. So p of x plus q of x, 5x squared plus 5x minus 10. Okay, so the next one, we've got q of x minus p of x. So that one, I put a minus and then I put the brackets for the second one, because otherwise I'm going to forget that I'm minusing off all those terms. So we need to remember that negative 1 is technically what we have outside the bracket, so all of these signs are going to change. And then just simplify again. So I get x squared minus 5x minus 6. So that's not too bad. And timesing them. Timesing them just means I'm going to expand out some brackets. I just have extra terms in there, slightly bigger expansion. So we've got we're going to do 3x times everything there, then negative 8 times everything there. So 6x4 plus 15x cubed minus 6x squared. I'm going to have to go on to the next line. Bad planning on my behalf. That's a minus 40x plus 16. Oh, no, I didn't. Good job, me. And then we just simplify, so collect like terms. Minus 22x squared minus 40x plus 16. And that's all expanding brackets is. So once again, practice 249, question 5.